Low-level languages. What does low-level language mean? A low-level programming language is a language that is very close to the computer's hardware. It is designed to communicate almost directly with the machine. In simple words, low-level language equals a language that talks directly to the computer. It is called low-level because it is close to hardware. It is far from human language. It is hard for humans to read. It is easy for machines to understand. So, low-level language equals human unfriendly plus machine friendly. What are low-level languages? Low-level languages mainly include machine language, assembly language. These languages control hardware directly, work very fast, need deep technical knowledge, are difficult to write and debug. Machine language. Machine language is the language of the computer itself. It uses only 0 and 1, binary. Example idea: 10101010101101110001. Computers understand this directly. Humans do not. So, machine language equals pure binary instructions. Characteristics: fastest language. No translator needed. Very hard for humans. Error-prone. Assembly language. Assembly language is a little easier than machine language. It uses short words, mnemonics, instead of zeros and ones. Example idea: MOVA, B, add A, 1. These words are easier than binary, but still hardware specific. So, assembly equals symbolic form of machine code. It needs assembler means to convert to machine language. Why low-level languages exist? Low-level languages exist because computers only understand machine code. Hardware needs direct control. Speed is critical. Memory must be managed manually. They are used when checkmark performance is very important. Checkmark hardware control is needed. Checkmark system-level programming is required. Features of low-level languages. Low-level languages are very fast, hardware-dependent, hard to learn, difficult to debug, not portable, memory handled manually. They do not hide hardware details, do not protect you from mistakes, give full control to the programmer. Advantages of low-level languages. Checkmark very fast execution. Checkmark full control over hardware. Checkmark efficient memory usage. Checkmark useful for system programming. Checkmark good for device drivers and embedded systems. They are best when you need speed and control. Disadvantages of low-level languages. Crossmark very hard to read. Crossmark very hard to write. Crossmark error prone. Crossmark not portable. Crossmark time consuming to develop. Crossmark needs deep hardware knowledge. So, powerful but dangerous. Real-life analogy. Low-level language is like driving a manual car with no safety features car. You must control speed, control gears, watch everything yourself. High-level language is like an automatic car. Easier to drive, less control, more safety. So, low-level equals full control. High risk. High level equals easy, safe. Where low-level languages are used. Low-level languages are used in operating systems, embedded systems, device drivers, firmware, microcontrollers, hardware programming. They are not commonly used for crossmark websites, crossmark mobile apps, crossmark business software. How low-level languages work. Flow. Program written in machine or assembly, then directly executed by CPU. OR. Converted using assembler. Flow. Low-level code means machine code means CPU means output. Common beginner confusion. Beginners often think low-level means bad. Think it is obsolete. Think it is unnecessary. But in reality, low-level languages are critical for hardware and OS. Simple definition. Low-level language equals a programming language that works close to hardware and is hard for humans but easy for computers. Important point. Low-level languages do not hide hardware, do not manage memory automatically, give full control, require careful programming. One mistake can crash the system. Summary. Low-level languages checkmark are close to hardware. Checkmark use machine or assembly code. Checkmark are very fast. Checkmark give full control. Checkmark are used in system programming. But crossmark hard to learn. Crossmark hard to write. Crossmark hard to debug. Crossmark not portable. They are powerful tools for experts, not beginners.